Hello, everyone. In this video, we will introduce two search algorithms, linear search and binary search. Search is the process of looking for a specific element in an array. Linear search, it works this way here. Now, suppose you have an array with these 5 elements, and you want to search if the key 8 is in the array. So it will search, begins from the first one, compare 8 with 85, there's no match, and then compare 8 with 81, and then continue all the way until there's match or until all elements in the array are compared and with no match. So this is called linear search. The implementation of linear search is right here. It's really simple here. You're going to have this linear search. This is the array, and to search the key in the array. It begins from the index 0 in the list to test if key matches list brackets I. If so, return true. If not, we're going to compare the key with the next element in the list. This continues all the way to the end. If there's no match after this loop, you're going to return false. But look, what we have is return an int. So if there's a match, you're going to return the index of the element in the list for that element at this index I matching the key. So return I. Otherwise, we're going to return -1. So this is linear search. Linear search, in the worst case, you're going to search everything in the list. It depends on the size of the list. If the size of the list is 100, you're going to take 100 comparisons. If you double it, and you're going to take 200 comparisons. So this is called linear search. If we already have the list is already sorted, we can use a more efficient search algorithm, and this is called a binary search. So now let's look at the binary search. Binary search assume that the list is already sorted. So let's say we have the list size is 15. So I'm going to reset it. So this is the list. See, this is a sorted. And you can click this reset to choose another list. So choose another list, choose another list. So everything here is sorted. And you want to find out whether this key is in the list. So what you're doing is this comparing the key with the element in the middle of the list. If the key is less than the middle element, and then you can narrow the search to the first half of the list. So let's look at the example now. We're going to perform the search.
Since 24 is less than 35, continue to search left.
Now here we have this 3 indices, low, mid, and high. So mid is low plus high divided by 2 in the mid. High is the range here, the high range, and here low is low index. So this is the low and high. It specifies the range for the list being currently considered. So now we're going to have this high move to right here before mid.
Since 24 is greater than 22, continue to search right.
Now we're going to continue to search right now.
Since 24 is less than 27, continue to search left. Since 24 is less than 26, continue to search left.
Now there's nothing
No
on the
match in the
left.
search is exhausted. -5 is returned.
So this algorithm is very efficient. If you have a large list, you can have a very quick search. So using binary search. So, but the prerequisite is that the list is already sorted. We're going to write this program and using those 3 indices, low and high and mid. So this is the binary search. Search the key in the list. Low is initially 0 and the high is the last index, is list dot length -1. So the mid is low plus high divided by 2. Now this is search one time, comparing key with list mid. If it's less, and we move to the first half, so high is now mid -1. Else if key is equal to list mid, so this match, return the matching index. Else, search is now in the second half, so the low is mid +1. So this is one time. So how do we do this repeatedly? So this is the second version, now expand it. So this is going to have this, put the while loop here, and this all this code is now in the mid, in the body. So this is a high. If high is greater than or equal to low, so we were going to continue. So while this condition is true, we're going to continue. And when high is less than low, that means you don't have anything left to search. So in that case, and you're going to return -1 here. Now, there's a better value to return rather than -1 is you can actually have this value indicating your insertion point. So here is the key. If the key is not in the list, so where you insert it, so we're going to return a better value indicating in that location. And so this is what we do here. We're going to have this value to return. It's return -low -1. So that's going to be, this is first of all, it has to be a negative value. So that means it is not in the list. Second thing is this, with this value, the low is the location. It's actually the location where you are going after this is all finished, and this low is the value indicating the index where you're going to insert this new element, insertion place. So let's look at this program here. Writing some code here is, so we're going to fill in something here. This is going to return mid. So there's a match. And here we're going to return -low -1. All right, so let's look at this for binary search, this 2 here. Now, this one, the index 0, 1, 2. So this index is 2. Now let's have this is 9. So what is 9, the index? You're going to search for this. 9 will be 0, 1, 2, 3, 4. So if you run this program, this will give you, that's 4. Return, so there's 2 return here. And now we get this is 4. All right, so now let's have this. 8. So what will be the return value? So 8 is going to be inserted right here at this location right here. This index is 0, 1, 2, 3, 4. So this is 4. It's going to be low. That's the low value. -4 minus 1, it's going to be -5. So this return value will be -5. So that's -5 here. Now, let's have this. I'm going to have this -4. So where are you going to insert -4? It's right here in this location at index 0. So that's going to be low, and -1, it's going to be -1. That is all for this 2 algorithms, linear search and binary search. Thank you for watching. See you on the next video.